All right, geometry. Chapter 10 is a little bit about area, and then he gets into some circles, and we'll move on to circles more permanently. So 10.1 and 10.2, we've already done area of triangles, rectangles, squares, even circles. So we're going to do parallelograms and trapezoids. Those are quadrilaterals. We spend a lot of times on parallelograms, not so much trapezoids, but you might see it on the ACT, so we want to try to show you. And again, we're very interested in how we can use these geometric shapes to model or describe objects in real life. Okay, so here is the formula for a parallelogram. It's the same as a rectangle. It's area equals base times height. There's only one issue here, right? And because a parallelogram is slanted, the height is not one of the sides. Notice that the height, as in all heights, is perpendicular to the base. So that's the height in this picture. Your base is going to be the length of one of the sides. Now notice here, right here, that in any parallelogram, you can actually use each side as a base and find a corresponding height. So for instance, in this picture, we're going to use this bottom side as the base as up top. So then we're going to draw the perpendicular here, and this will be our height. They call it altitude. It's the same thing. Altitude and height, altitude, same thing. So now here in this picture, we're going to use this side as the base. So now what they've had to do is if we start from here and we go perpendicular, we're actually going to miss that side. So we have to extend it. And now this could be considered the height. So beware that whenever you do a parallelogram problem, there's always two ways to find the area because there's a base and height pair for each side. All right. And now let's talk about trapezoids. So first of all, the height of a trapezoid is going to be perpendicular between the bases. So again, anytime we're talking about height or altitude, we should be thinking perpendicular. Now, just to refresh your memory on a trapezoid is a trapezoid because it has two parallel bases, okay? Base 1, base 2. So there's that height going perpendicular between the two bases. So here's your fun-filled trapezoid area formula, 1/2 the height times base 1 plus base 2. Be very, very, very careful that you do include the parentheses because, again, you need to do this addition before this multiplication. Word of operations will not do that without the parentheses. All right, so this assignment is going to be both in Edulastic and Delta Math. We'll start in Edulastic, and then we'll move into Delta Math. So this video will contain some examples from Edulastic. Okay, so here's our first example, just a basic find the area of the parallelogram. So again, in this parallelogram, you have two sides. You have 4 and you have 5.8. And then you have this height drawn. So this 3.5 is going to be the height that you have to use. So the question is the 3.5 the height of the 4 or the height of the 5.8? Well, this 3.5 is the height connected to this extended side. This is going to be the base of your formula. And this base is congruent to 5.8. So we're going to use 5.8 as the base. 4 is not going to be used in this problem. So to find the area of this parallelogram, base times height, 5.8 times 3.5. I'm going to do that off to the side. You can just do that in Desmos Graph and Calculator as well. So 5.8 times 3.5, and I got 20.3. So in here, 20.3. And again, we're making you choose the units. So notice they're meters. So this is area, meters squared. All right. Very good. Next problem. Okay, this time it says find the value of h for the parallelogram, round to 1 decimal. So you have this height right here, right? That's our h. It is perpendicular to this side right here. This side is going to be congruent to 13. So the height h and this base 13 could be used to find the area. So area could be base 13 times height h. But that's not going to help us because we don't know the area and we don't know the height. Well, what about the other base height pair? This 12 is another height perpendicular to the extension of this bottom side, this base. So now we can use 18 as the base. And we can also calculate the area of this trapezoid by using 18 times 12. And now we can find the area of the trapezoid. 18 times 12 is 216. And now that we have the area of the trapezoid, we can take it and substitute it into this first equation. And now all that will be left is our height. So 216 equals 13 times h. We're going to divide both sides by 13 to get the h all by itself. And 216 divided by 13 is, it says round to one decimal. I got 16.61. So the 1 does not change the 6. So your height here is 16.6. I said it doesn't change it, and I changed it. I was lying to you. 16.6. For this one, there's no unit box because they did not provide units. Again, this is a perfect illustration of why a parallelogram has two base height pairs. All right, let's do one more problem on this video. Okay, so the next problem says a bakery has a 50-foot by 31-foot parking lot. The 4 parking spaces are congruent parallelograms. The driving region is a rectangle, and the 2 area for flowers are congruent triangles. Find the area of the paved surface. So basically what we have to do is we have to find the area of this rectangle, and then find the area of one of these parallelograms and times that by 4 because they're congruent parallelograms. Well, let's do the area of the rectangle. So area of the rectangle is base times height. This is your base, 15 is your height. So 50 times 15, when you multiply that out, that's 750. Okay, and that would be feet squared. So now we need to find the area of a parallelogram. So we have that this is 10. So I believe that's the base. So the question is, what is the height going to be that drops down to that base? Well, we can use 15 and 31 over here. 31 goes from top to bottom. 15 is just the rectangular paved part. So to find this up here, why don't we take 31 minus 15? And that's 16. From here to there, I'll do it in a different color. Let's do it in yellow. That is 16. And that is also the same height over here. This is 16. And we're going to find the area of one of the rectangles by doing base 10 times height 16. So the area of one of the parallelograms is going to be 10 times 16. That's 160 feet squared. So now the total paved area, so total, let's do area with a T. Area total is going to be the rectangular plus 4 times one of the parallelograms. And when I do that in my calculator, I get a total of 1390 feet squared. 1390. Okay, I'm going to stop the video here. I do have 2 more. Well, let me see real fast. I'm going to pause. Yes, I'm going to stop the video here. I have 2 trapezoid problems I'm going to do remaining on this assignment. All right, so next video is coming.